Hi, in this video, I'm going to estimate two stages least square model as well as instrumental variable regression models in R programming language. I recommend that you watch this video up to the end so that you could understand and you could learn how to estimate and how to interpret the results of these two models. So let me start with the introduction. I'll be using this data set wage 2. This data set is available in Woolridge datasets in his econometrics book. In this data set there are 17 variables, but for today's model I'll be using first log of wage as dependent variable and education level of the respondent as my one of the independent variables, and then I'll be using south as one of my independent variable, which is categorical, having two categories. It is equal to 1 if a person lives in the south and 0 otherwise. Then I'll be using two instrumental variables instead of education, and the instruments that I'm using instead of education are father education as well as mother education. So I'll be doing this in two different ways. One, I'll be regressing instrumental variable regression, and secondly I will be using two stages least square. In the first stage I'll be regressing education on mother education, father education, and one of the explanatory variables, that is categorical variable south, and then in the second stage I'll be regressing log of wage on education, and then subject to the condition that I'll be using the predicted values of the first round regression, and then I'll have this as a two stages least square. After that I'll also run a OLS model, and then I'll compare the results of all the three models, that is instrumental variable regression model, two stages least square model, and ordinary least square model. So to understand this, kindly be careful, be attentive, and watch this video up to the end. Now I'll go to R. This is R, and there are four areas. The first area is editor window. Here is the console area, here is the environment area, and here below in the right hand in the bottom there are tabs like files, plots, packages, etc. I have already opened this file, and this file is known as wage 2. There is another way, another data set also available online, that is titled as wage 1. This particular data set is known as wage 2, and in this data set there are 17 variables and a total number of 935 observations of these 17 variables. So let me show you the data set. This is the data set. Here we have wage as monthly earning, hours, average weekly hours. This is IQ score. This is knowledge of the world work score, education, experience, and there are so many other variables. The last variable, that is log of wage, we will be using this as our dependent variable. And here MEDUC and FEDUC, these are mother's education and father's education. We will use these variables as instruments in two stages least square as well as the instrumental variable regression model. So with this I'll go to my data set, and first of all I want to declare wage 2 as data. That is, it will create another file here, and that will be titled as data. In order to avoid these capital letters, let me give this name data with small cases. So if I click on that, it is exactly the same file with the wage 2 title. So there are 935 observations of 17 variables. As I mentioned, I want to run a multiple regression model of wage, which is a response variable on two explanatory variables. One is education as a quantitative independent variable, and the other one is a qualitative variable which is titled as south. I need to convert south variable into a factor variable, because initially the south variable is a categorical variable, but it has two codes, 0 and 1. 1 means if a person lives in south, 0 means if he lives somewhere else. So I want to I would like to convert this variable into a factor variable, and I'll assign some labels to 0 and 1. So 0 will mean other and 1 will mean south, and to do that I give this command. So if I do this, this has created another variable in data. So let me show. Previously the last variable was natural log of age. Now the variable south has been declared as this is south, this is south, this is 0 1, but now we have converted this into factor variable. So now this has two labels, other and south. Okay, after that I would like to show you names of the variables. So the command is names and within parentheses data. If I run this, it shows us these are the various names of those variables. Now, as I mentioned, that log of wage is my dependent variable, so I'll represent that by y. So y is equal to data $sign followed by log of wage. So log of wage variable within this data set data that will be titled as y. So let me do that. So here it says y values are these numbers. So y basically means natural log of wage. One of my explanatory variable was education, so I want to title that as a x1. So x1 is my first variable, which is education. So I have x1. Similarly, south, which is a categorical variable. So now I will write dot f, because this is my factor variable. So x2 is my factor variable, and I'll be using father education and mother education as instruments. So I'll create z1 and z2. So z1 is an instrumental variable instrument for education. So let me run this, and let me also run this one. Now y is natural log of age, x1 is education of the respondent, x2 means this is a categorical variable which is equal to south if it is coded as 1, and equal to other if it is coded as 0. Z1 is a father education and Z2 is a mother education. Now first I would like to run instrumental variable regression function. Let me call it IEV underscore model. So IEV model will mean instrumental variable regression model, and the formula is that instead of simple regression I use IVReg. So IVReg stands for instrumental variable regression model, and then this is the formula. Y, which is natural log of age, that is regress on x1, where x1 is education and x2 is south as a factor variable, such that z1 and z2, which are instrumental variable used instead of education, plus x2, where x2 is a categorical variable south dot f, and data is equal to data, because the name of my data set is data. So if I do that, let me run it. So in instrumental variable regression model has now been estimated. Let me show the summary of this model. Let me summary. Okay, now I will have to change the name, because I use a IV underscore model. So this is the correct name of this instrumental variable model. So it will now give us summary of the model. So this is the summary of this instrumental variable regression model. So this is the formula that we just used for this. This is the description of residuals: minimum, first quartile, median, third quartile, maximum. Below this we have coefficients, that is the estimated coefficients of the intercept, education, as well as the factor variable south. So this is okay, let me okay, so this basically means that other things remaining the same. For 1 year increase in education, the log of wage will increase by 0.093. This is the factor variable south. It means the value of the natural log of wage will be less by 0.1206 as compared to a person living in other area than south. So it means on the average the wage rate of those living in the south is less than those who are living in other areas. Then we have residual standard error, which is also known as mean square error, and this value is equal to 0.4025 with the 719 degrees of freedom. R squared value is equal to 0.08, adjusted R square is equal to 0.07, and wall test value is 31.06. P value is very, very low, so it means that overall this model is significant. This regression estimated equation is significant. So here x1 is used as a, in this model is used as a instrumental variable because we have z1 and z2 here. After that, let me estimate two stages least square model. So in the first stage model, we will regress education of the respondent on education of his or her father and education of his or her mother plus categorical variable south, and data is data. So if I run that, this will be the first stage regression. So first stage equation has been estimated, but in this the dependent variable is the education of the respondent, which is regressed on his parents' education, that is education level of his mother, education level of his father, as well as education level of his mother, and categorical variable south. We will now compute x1 head, that is the predicted values of the dependent variable education, and the formula is this: predict first stage new data is equal to data. So it will create new data which will have a prediction of the first equation. So yes, it has done that. After that, I'll run the second stage equation, in which I'm regressing log of wage on predicted values of education plus the categorical variable, which is south, and data is equal to data. Let me run it. So the second stage equation has also been estimated. This is the first stage equation. In the first stage equation, the dependent variable was education. In the second stage equation, the dependent variable is a natural log of wage, and the dependent quantitative variable instead of education is the instrument of mother and father education. Now let me show summary of this second stage regression equation, and this is the estimated equation of the intercept. This is the estimated coefficient of the predicted value of the education, and this is the estimated coefficient of south. Again, this is a residual standard error, this is multiple regression, and this is a adjusted regression, and this is a F statistic. Remember, in the two-stage D square we have F stat, which is significant, but in the instrumental variable regression we have wall statistics, and both the models are significant. After that, I would like to regress OLS equation by LM command. in which y is my natural log of age, x1 is actual education of the respondent, x2 is the categorical variable, and data is data. So let me run it, and the OLS model has been estimated. Now I will show summary of this model. This is the summary of this model. Again, the coefficient for the south is negative. Coefficient for x is x1 is 0.05, and this is the intercept. In this model, the R square is a little bit higher than the two stages least square and the instrumental variable regression model. Similarly is the case with the adjusted R square, and I have f statistic value 66.41 and so on. Now let me show you the combined coefficients of instrumental variable regression, the second stage regression, and the OLS model. So let me highlight all the three and run it. So this is instrumental variable regression function, and the coefficient of the intercept is 5.56. Exactly in the two stages least square, the coefficient of intercept is exactly the same. For education, for instrumental variable, instead of education, the coefficient is 0.09344, and in the two stages least square, the coefficient for the predicted values of education, these two coefficients are exactly the same. Similarly, the coefficient of the categorical variable south, this is exactly the same for both the model. So it means that no matter whether we will use instrumental variable regression model or we use two stages least square model, coefficient will be the same. But experts say that instead of using the two stages least square, it is better to estimate instrumental variable regression model, because the errors in case of instrumental variable model are less than those errors which are found in case of two stages least square. Finally, we will compare the results of these two models with OLS. So here in case of OLS, the coefficient of the intercept is 6.064, and for the two stages least square and instrumental variable regression model, the intercept is 5.56. For actual education, the intercept is the estimated coefficient is 0.056. Since this variable is endogenous, so if you use this in OLS, then it will not correctly, it will not be valid. So the correct estimated coefficient for education when it is correlated with the error term, we should not use OLS. We should use instrumental variable regression, or we should use two stages least square, because here the instrumental variable for education is strongly correlated with education itself, but it is not correlated with the error term. So the coefficient of the categorical variable is also different in OLS as well as in instrumental variable regression function. So the conclusion is that whenever any of the independent variables is correlated to the error term, then in that case, if we use OLS model, then our results will be biased. They will not be valid. So in those cases, you should use instrumental variable regression model, which is much better than OLS as well as the two stages least square. Although all the coefficients in case of two stages least square and instrumental variable regression model are the same, but in case of the two stages least square, the errors of the model are greater than the errors of the coefficients in case of the instrumental variable regression. So the conclusion is that whenever we have any endogenous variable, then in that case we should use instrumental variable regression model. I hope this was useful for you. Kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get notifications about my other videos that I will be uploading for you. Thanks for watching. Kindly share this video with your colleagues, with your friends, and in various WhatsApp groups so that it could reach to the maximum possible number of people. Thanks for watching.